Hi, this is Dr. M. Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, I'm going to discussing about zinc air battery. What is a zinc air battery? Construction and applications of zinc air battery. Some general information about zinc air battery. So here, activated zinc air battery, it will be activated when oxygen is absorbed into the electrolyte through a membrane. Usually reaches full operating voltage within 5 seconds of being exposed to air. Oxygen from environment, it will diffuse directly into the battery. Electrolyte that catalytically promotes the reaction of oxygen but is not diffracted or transformed at discharge. Basically, zinc air battery is the example for primary battery. Here, before going to the construction and working principle of zinc air battery, first we have to know what is a primary battery and what is a secondary battery, and what is the major differences between the primary and secondary battery. So, coming to the primary battery, it is a non-rechargeable batteries. So, as we know, batteries are classified into two types, depends on type of reaction takes place. In primary battery, only electrochemical reaction takes place. Here there is no electrolytic reaction. That means whatever chemical present in the battery, that is converted into electrical energy. That means chemical utilizes to produce electrical energy. So that is the electrochemical cell. Electrochemical cell. Here chemical energy converted into electrical energy. In primary battery, only irreversible reaction takes place. There is no reversible reaction. Irreversible reaction in the sense only discharge of battery, discharging process of battery takes place. There is no charging in primary battery. So that's why it will be discarded after single usage. So that is a primary battery. Whereas coming to that secondary battery, here through discharging process, chemical energy converted into electrical energy, chemical to electrical energy, and through recharging process, electrical energy converted into chemical energy. So in secondary battery, there are two types of reactions are possible, that is discharging and charging. So during discharging process, chemical energy converted into electrical energy. Through recharging process, electrical energy converted into chemical energy. That means secondary battery can act as both electrochemical cell as well as electrolytic cell. Okay, next going to the construction and working principle of zinc air battery. Here, zinc acts as a anode and porous carbon. Porous carbon act as a cathode. And here electrolyte is KOH. Potassium hydroxide act as a electrolyte. So zinc air battery act as a primary battery. That's why only discharging process is possible. So there is no recharging of zinc air battery is not possible. So here zinc act as a anode and porous carbon act as a cathode and electrolyte is potassium hydroxide. Next coming to the construction, zinc which is act as a anode and porous carbon which is act as a cathode, both are connected with external wire. We can see here construction, and porous cathode is coated with Teflon which will avoid the passage of moisture from environment to battery through oxygen. So that's why this porous cathode is coated with Teflon. It inhibits the passage of moisture along with oxygen from environment to battery, inside of the battery. So it is an inlet for air and it is outlet for excess of air. Only some amount of air is passed through the porous carbon which is act as a cathode into the cell. So coming to the reactions, at anode, before going to the chemical reactions, first electrolyte that is KOH dissociated into K plus OH minus. KOH potassium hydroxide dissociated into K plus OH minus. So oxidation takes place at anode. Here zinc acts as a anode. Zinc loses electrons through the process of oxidation and it is react with hydroxide ion which is coming from dissociation of electrolyte, forms zinc oxide H2O and the liberation of electrons. Next coming to the cathode, these whatever electrons releases through the oxidation process at the anode, that electrons are moved towards opposite charged electrode that is cathode. There oxygen is passes from environment to cathode. That oxygen by the gain of electrons forms hydroxide ion. Coming to the overall reaction, zinc react with oxygen forms ZnO. Here zinc and air are fed to the fuel cell. ZnO is removed by the flowing electrolyte. So that is a construction of zinc battery. You can see here positive electrode and negative electrode and air electrode, passes through the pores, that is a porous carbon. Next, coming to the rechargeability. Zinc air batteries are not rechargeable, as we know. Why? Because here only electrochemical reaction is possible. These are act as a primary cells. Zinc air fuel cells are rechargeable. So, leave out as developed rechargeable zinc air batteries. Advantages. So, what are the advantages of zinc air battery? Weight. It is not necessary to carry a second reactant, and high energy density, and competitive with a lithium ion battery, and cost of zinc air battery is very less, and flat discharge voltage. With regarding safety, it don't require any volatile materials, so zinc air batteries are not prone to catching fire like lithium ion batteries. Excellent shelf life with a self-discharging rate of only 2% per year. It is available in a range of button and coin cell size. Rechargeable high power fuel cells in the process of development, and environmental benefits. And comparing lithium ion battery, zinc air battery produces very less hazardous nature to the environment and high volumetric energy density compared to the most primary batteries. And next, coming to the disadvantages, major disadvantages of zinc air batteries. So it is sensitive to extreme temperature and humidity conditions. And carbon dioxide from air forms carbonate, which reduces conductivity of a battery. High self-discharge. After activation, chemicals tend to dry out and the batteries have to be used quickly. Although recharging is possible for fuel cells, it is also inconvenient and it is only suitable for high power types. And zinc air batteries must be larger to satisfy high current needs. And high power batteries use mechanical charging in which discharged zinc cartridges are replaced by fresh zinc cartridges. Therefore, the used cartridges must be recycled, have flooding potentials, and limited output. When zinc turns it into zinc oxide, it expands and space. Next, common uses or applications of zinc air battery. Most of the zinc air batteries are used in hearing buds, hearing equipments, and watches, and also used in mobile phones and digital cameras, pages, communication devices. Pages are nothing but communication devices, and power sources for electrical lenses, recharging lithium ion batteries. And next, coming to transportations also require zinc air batteries like cars and electrical vehicles, especially and buses. Nowadays, zinc air battery is used in electrical vehicles also. And small differences between the magnesium air, lithium air, and zinc air batteries. Let us see what are the major differences. So first, let us discuss the differences between the Mg air and lithium air batteries. So Mg air batteries are high energy density batteries and lithium air batteries are density of fuel cells, and magnesium air batteries are safe. Usage of magnesium air batteries are very safe. Usage of lithium air batteries are polypress. And expensive. Magnesium air batteries are inexpensive, not being widely used, whereas lithium ion batteries are only single use and rechargeable. Self-discharge in neutral solution. Magnesium air batteries can self-discharge in neutral solution. Lithium air batteries are rechargeable in lithium metal air core. Reaction mechanism of magnesium alloy anode and effects of different additives on performance of magnesium alloy in a solution. Lower self-discharge rate and longer shelf life for lithium air batteries. So these are the major differences between the magnesium air and lithium air batteries. Coming to the differences between the zinc air versus aluminum air batteries. So aluminum air batteries are produces electricity from the reaction of oxygen in the air with aluminum, whereas zinc air batteries are reaction of zinc with oxygen in the air. So they has one of the highest energy densities of all batteries, not widely used. That is cost, shelf life, startup time, and byproduct removal, and which have restricted their usage to mainly military applications. And electrical vehicles with aluminum batteries could have potentially 10 to 15 times the range of lead acid batteries with a far smaller total weight. These are the small differences between the zinc air battery and aluminum air batteries. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.